Okay, so lesson 2 from Unit 4 is going to be volume by cross sections. What we're going to be doing here is setting up the integrals needed to find the volume of a solid whose base is the area bounded by the curves y equals square root of x and y equals x, and whose cross sections are perpendicular to the x-axis, and whose cross sections perpendicular to the x-axis are the following shapes. Okay, so I'm going to be doing a bunch of shapes with you. Okay, number 1, let me draw this picture. So you have the square root of x, right? And you have y equals x. Okay, so we have y equals x. And so you could see that these intersect at 0, 0 and 1, 1. All right, so you have to picture a volume of a cross section as basically being a pop-up book, like a kid's pop-up book. And the shape is popping up out of the book and it's just going across your plane. Okay, so let's say the cross sections are squares. So what this means for us, all right, you have to picture this, is here we're going to have squares. Okay, these squares are going to be popping up out of the page, facing toward you. Okay, but there's going to be an infinite number of them. I'm putting the base. Okay, so let's think about the base of the square. So if we draw the square, okay, the base of the square is your upper curve minus your lower curve, right? But both bases are the same. So when you go to make the integral is going to be square root of x minus x squared dx from 0 to 1. Okay, so there's a basic formula. Okay, the basic formula is that if you have your upper curve minus your lower curve, if we call that just S, let's say we call that S, okay? Upper curve minus lower. Okay, if we call that S, okay, then the integral in general from A to B, if you have a square, would be S squared dx. Okay, so those are squares. All right, now as far as rectangles go, they give you specific details. So they would say something like a rectangle with a height of 2. Okay, so if I draw the rectangle now, picture these being rectangles coming out of the page. So the height is going to be 2 no matter what, but this is going to be the base of my rectangles, right? So the base of my rectangles is still going to be square root of x minus x. Okay, you may want to put it on the other side. Maybe easier for you to understand if we put it there, since these are perpendicular to the x-axis. All right, so the general height is 2, and it's square root of x minus x. So your volume, okay, this is volume that we're finding here, kids. The volume would be the integral from 0 to 1 of 2 times square root of x minus x. Okay, now the dx, you understand the dx is the thickness of each of these little rectangular prisms, okay? So in the last one, for those squares, there's an infinite number of them with infinitesimal thickness dx, and that's what's going on. Okay, let's say they said a rectangle with a height twice the width, okay? Or maybe they'd say length, depending on how they word it. So in this case, your volume would be one of the sides is twice, right? So I'm just going to leave that coefficient outside. But then both sides, okay, besides one being twice, okay, so my height is twice this function now. and then the other side is square root of x minus x. So it helps to draw these cross sections. That's the one thing I want to point out to you. Okay? Dx. All right, so let's say that the cross sections are circles. Now, this would be a pop-up book. If it's circles, okay, and here's your surface, the circles would be coming on both sides of your plane. You'd have semicircles popping up at you and semicircles going through your page the other way. Okay, so just be as creative as you want. So for your circle, okay, this is your diameter for each of your circles, right? So for your circle, think about it. What is the diameter? So your diameter is the square root of x minus x. Okay, but the area of a circle is pi r squared. So if you think about it, you would have, since the radius is half of the diameter, right? So your radius would be square root of x minus x over 2. But we're squaring it, okay, times pi. Now, I'm getting volume here. So my volume would be pi times r squared times h, right? Times my height. Now, my height, keep in mind, is my thickness of each of my little cylinders. So that's my dx. So I would have the integral, okay, from 0 to 1. We have the same base here. So now we could factor out this here and just make it pi over 4. Now you can memorize this, kids. Just memorize when you see a circle, you're going to factor out pi over 4, and then it's just going to be upper minus lower if it's perpendicular to the x-axis, dx. Okay? Now what about semicircles? Okay, so think about the area of a semicircle. So the area would be half pi r squared. So how would this formula change? Instead, it would be volume is pi over 8. I hope that makes sense. I just multiplied by a half. Okay, and you have to be expected to do these out. But in this lesson, I'm just setting them up. All right, let's talk about what if the base was an isosceles triangle with one leg on the xy plane. An isosceles triangle with one leg on the xy plane. An isosceles right triangle, I meant. So picture your two curves again. Okay, picture that here's a leg, right? This is one leg. So then your other leg would be popping up out of the page. So, okay, this leg would be square root of x minus x. Okay, your other leg popping up out of the page would also be square root of x minus x. Okay, and your area is half base times height. So it would be half square root of x minus x squared dx from 0 to 1. Okay, so your general formulas here. Okay, for the first one, your general formula is volume equals pi over 4, the integral from a to b, s squared dx. The second one is volume equals pi over 8, the integral from a to b, s squared dx. And now this one is volume equals 1/2 the integral from a to b, s squared dx. Okay, where is there an issue? There's an issue, okay, this is more difficult, when you have an isosceles right triangle with the hypotenuse on the xy plane. So, okay, if you have the hypotenuse, and the hypotenuse has some expression, whatever you want to call it, right? So, I'll just call this A. Here's my hypotenuse. Now, these are the same. So you remember the formula that each of these would be a divided by square root of 2, because this is a 45, 45, 90 right triangle, right? Okay, so when we're talking about the actual area, though, the actual area would be a over rad 2 times a over rad 2 times a half, because it's a triangle. So this would be a squared over 4. Okay, but a, keep in mind that a itself, okay, if you picture this, your a here is this hypotenuse, right? And this hypotenuse is rad x minus x. So you end up getting rad x minus x squared. I'm going to factor out the 1/4 from 0 to 1 dx. So in general, this formula, when you see hypotenuse on the xy plane, it's 1/4 the integral from a to b s squared dx. Okay, the last one is the equilateral triangle. Okay, so the equilateral triangle so picture an equilateral triangle. Okay, here's one side, the other two sides are popping up. Okay, well, if you picture one of these equilateral triangles, right? This is rad x minus x, as you know. So are all the other sides, but now I need the height. So this is a 30, 60, 90 triangle. This is 60, this is 30, right? So whatever the base is, the height, this height, is the base, right? Times rad 3 over 2. So that means that the height, in this case, would be square root of x minus x times rad 3 over 2. So in other words, if you see this, right, keep in mind now the area, however, we need to take half of that. So it's half times rad x minus x times rad 3 over 2, or square root of 3 over 4. Oh, well, I need to do base times height. So this is, right, this is squared. So square root of 3 over 4 times rad x minus x squared. So the volume is just repeated over the distance. So you'd have square root of 3 over 4, 0 to 1, square root of x minus x squared. So most people just memorize that the coefficient that goes out front is square root of 3 over 4 when you have an equilateral triangle whose one side that is in the xy plane, right? Okay, kids, so the general formula would just be square root of 3 over 4, the integral from a to b, s squared dx. All right, we'll continue this in class, but you will have to ultimately memorize these formulas. Okay, I will also post a formula sheet to Google Classroom. Thanks.